Right. Thank you, Paul. Thank you all for attending today's webinar. I think the title is very broad. It covers the science and the communication of energy efficient indoor environments. So we have heard an overview by Professor Paul Ruyssevelt on the AIVC, what it's about. And we also heard 6 technical presentations from 6 AIVC annexes. So I'm going to quickly go over all these presentations. The EVC overview by Professor Paul Ruyssevelt, I think is very comprehensive. It really tells us what EVC is about. Its scope is really about energy in building and communities. But energy itself is not alone, so we cannot just do the energy without considering indoor air quality and comfort. So I think so energy here is not a narrow wording. So EVC currently has 5 main themes. So it has totally 27 participating countries. Up to now, the Annex, the EVC has sponsored 86 Annex projects and 6 working groups, and based on the task shared working mode. Currently, there are 20 existing Annexes and 3 working groups ongoing. The project results are broad, including, of course, the reports and fact sheets, handbooks, guidelines, and a lot of papers published. So you are really welcome to visit the EVC website, so you can download all the information here about the current and previous Annex projects. The target audiences are government agencies, industries, and academia. So it actually has a broad kind of audiences. So this is what we heard from Paul regarding AIVC. About the technical presentations, the first presentation given by Peter Wouters about the Air Infiltration and Ventilation Center, AIVC. Well, first of all, this is a very unique Annex project. You see the number Annex 5. So that means it's really a long history Annex, already more than 40 years old. Typical Annex project only lasts for 4 years, but this one, because ventilation is so important to energy and many other issues, so the AIVC decided to keep this Annex for such a long time. So Peter talked about the events of AIVC, a lot of events, and also a lot of resources available through the website, papers and technical reports, and also newsletters. And AIVC is very active research center. You can consider this as a broader Annex project. So they have a focus fields of projects. They have their own managing boards. And so the current focus field includes the smart ventilation, ventilative cooling, indoor air quality, and also air tightness. The AIVC also works with some of the relevant Annex projects. So of course, the COVID-19 and ventilation has a direct connection. So they are currently working on this new topic within the AIVC. So this is very brief information about the first presentation by Peter Wouters about EVC Annex 5. Then about Annex 868, I think the topic is very interesting. It's about high IAQ in low energy buildings. This is led by Professor Carsten from Technical University of Denmark. Again, we are talking about low energy buildings, but this cannot be compromised. IAQ cannot be compromised. So the goal is to provide comfortable and healthy indoor environment in energy efficient buildings. So the activities of this Annex is also very broad. They cover definition and indicators, And what I found very interesting is that they provide indoor air quality and energy dashboard, which is very illustrative and very easy to use. They also work on the pollutant loads. It's similar to energy load, but this is about the pollutants such as volatile organic compounds, how much they are generated from different kinds of emission sources, such as the materials, the cooking, etc. And then they work on the modeling and how to design energy efficient and high indoor air quality buildings, and also control strategies, which is not only related to the source, but also highly related to ventilation and how to maintain the buildings. And they also collected a large number of case studies, including both the design and operation stages. And out of the 24 case studies, there are 7 low energy buildings from different countries. And currently, the project reports are already available. The next presentation given by Professor Yingxin is Annex 69. This is about adaptive thermal comfort in low energy buildings. So Professor Zhu first talk about why adaptive thermal comfort, the appropriate indoor thermal environment. And so meaning you can tolerate broader temperature range, and so that can result in low energy consumption in buildings. And the project also developed the mechanism models, and also very significantly, they developed a new database covering 6 continents and 22 countries. And the model has been applied in mixed mode buildings, and they shown that the reasonable building design and gives 4 examples in 3 different countries, including China, Australia, and India. And also Professor Zhu talked about the personal comfort system, which is to provide the individual control of a microclimate using a number of technologies, heating, cooling, chair, etc. So all of these would be able to provide high energy saving potential while also meet people's thermal comfort requirements. We also heard about interesting IVC working group by Helmut, Strasser, which is about cities and the communities. And so in the background session, Helmut talked about the carbon emission in cities, and he mentioned cities are at the heart of the decarbonization efforts. So decarbonization is really the goal of this working group. And he talked about the barriers and challenges, and also analyzed the city's needs for decarbonization efforts. So the working group includes 3 thematic priorities, including technologies, strategies, which is mainly focused on planning, and also data, tools, and methods. Well, the working group has analyzed a lot of questions, and they have gathered lessons learned. After a long couple of years of effort, they actually provided a proposal for a new TCP on decarbonization in cities and communities, which will be a very interesting effort. So we look forward to this new TCP to be approved and actively participated by different countries. The next presentation given by Rolf Frischknecht is on the life cycle environmental impacts caused by buildings. And the goal, I think, is very clear. EU has set up the goal to reach net zero emissions by 2050. So 40% of the emissions is caused by buildings. So it's very important to consider that, take that into account. And they use a life cycle assessment approach, which means it considers the whole life cycle, including the material, construction, maintenance, and the demolition stage. The Annex project covers 5 subtasks, including methodology guidelines, assessment workflow and tool, case studies, building life cycle assessment database, and the determination. He also gives a very detailed analysis about the typology of net zero building approaches from the energy demand and production point of view, and also provide a package for national building life cycle assessment, which is very useful information for the low carbon development in the future. And then the last but not the least, also very interesting project is Computation and the Living Laboratory platform by Professor Carsten Voss. Well, this is actually based on the experiences learned from the solar decathlon computation, but they developed this into an IEA Annex project. And there are three major subtasks, including science and technology, computations and the living labs, and also communication. Very interestingly, well, actually for this kind of computation, they set up the design data, for example, set up the maximum power, 15 kilowatt peak, and all the way down at the beginning 15 and then 10, and then now it's 5. So it's lower and lower. And also the computation has to show monitoring data, including both the consumption side and the production side. Well, I think this project also gives a very good analysis how to link the computation to building science. I think this is what the education is all about. Through this kind of computation, really students can learn a lot and get more experiences about the building science. And of course, he also lay out the lessons learned, the impacts, and also the performance of the computation project, which is very interesting. So I think this is what I just very briefly can summarize. Again, the topic today is very broad. It covers ventilation, indoor air quality, energy, thermal comfort, carbon emissions, and of course, computation. So I would like to take this opportunity to thank all the presenters for their very interesting overview and insights into these very important Annex projects. And also, I would like to thank all the participants who are listening to today's presentation. So there will be a survey form. So I would encourage you to fill out the survey form after you hear this session, so we can hear back from you, and so we can actually have a better project being implemented in the future. So this is all what I want to say. Thank you, and Paul, I hand it over back to you.